Right, here's a great question that's going to build on what you just learned in the last question. Remember the rancher question? You're given a length and a width, an amount of fencing, and you want the maximum area. Perfect. This is going to be the same kind of idea, but just going to build on that concept a little bit. Let's read the question. It says, you're an event planner hired by the City of Edmonton. Congratulations. You're going to help organize the upcoming Edmonton Heritage Festival in Hawrelak Park. Now, each pavilion is mandated to have an eating area, okay, as well as a performance area. That word tells you length times width right away. But you want it to be both of equal size. Okay, so there's the performance area, there's the eating area. Groovy. Now, being that it's an area, remember your area formula. Your area formula is always going to be, no matter what, length times width. That's how it works for a rectangle, right? Now, each pavilion is allocated 90 meters of fencing. That means the 90 meters of fencing has got to go all the way this way, down, around, and through this middle section. Boom. That's your 90 meters of fencing. So think about this. What do you have? Well, this whole length right here is in fact still a length. I know it's cut in half, but aren't you going to put the fence all the way across? Of course you are. And so that means if this is a length here, is this not a length down here as well? So think about it. So far, for that 90 meters of fencing, you have two lengths, don't you? But now, here's where the little kind of extra comes in. You've got this guy right here with this, which is a width. You've got this guy right here, which is a width, and this guy right here, which is a width. So you, in fact, have three widths. So you got two lengths and three widths that make up that wonderful enclosed performance eating space. See how it works? Great. Now, what else do you have here? Well, you have this area formula. Well, and you know you want to maximize this. Why? Because read on. It says you wish to maximize the area. Soon as you say the word maximum or minimum, it's automatically a parabola. Well, so far, this does not look like a parabola. Look at your area formula. You want area, of course, to be a maximum. So this is going to be still length times width. Now, I know what you're saying. Well, why isn't this doubled here, sir? No, this is the whole length multiplied by the whole width, not a portion of the length. The whole length multiplied by the whole width, you're going to figure out the maximum area. And if you want, you can divide it by 2 and find out what each area is. Do that at the end. For right now, keep it simple. So how do you end up calculating this? Well, guess what? You're going to have to realize that this is a system of equations, and you're going to have to substitute one equation to the other. So you know what? Here's what I'm going to ask you. What do you want to solve for? Do you want to solve for length, or do you want to solve for width? Well, you know what? I think I'm going to solve for length. So I'm going to grab this formula right here, which we know is 90 equals to 2L plus 3W. I'm going to solve for length equals 2. That's what I'm going to solve for. So that means I'm going to bring the 3W over, so subtract 3W for both sides. So now I got 90 minus 3W equals to 2 lengths. And now all I have to do is divide by, you got it, divide by 2. That cancels, leaving me length equals, now remember, divide that into 2, divide that by 2. So 90 divided by 2 is 45 minus 3 over 2 W. There's your length. Now, what are you going to do with that? Real simple. If that's what your length is, go to your other formula here and pop it in there. So what are you going to end up getting? Oh, you're going to get something very, very pretty here. Okay? You're going to get area max. So area max is going to be, there's the length, which is this guy right here, 45 minus 3 over 2 W times the W. And lo and behold, look what happens when you distribute the W. You got 45W, so this becomes 45W minus 3 over 2 W squared, and there's your parabola. And there's your area formula. And that, ladies and gentlemen, is what you're going to put into your calculator. Oh my goodness. Now, that looks like a nightmare. Really? For a calculator? No, that's going to be easy. So what are you going to find? Obviously, this is opening down. So your formula is going to look something like this. You want to find that maximum, which is going to give you your maximum area. There's your area here, following whatever that dimension is on the x-axis. Well, since we don't have x, we have w's, so guess what you're going to find? That's going to be your w value for the area max. Oh my goodness. Okay, well, enough of that. Let's just start throwing this in the calculator. So remember, this is 45 minus 3 over 2w squared. Okay, here we go. So 45w, this guy. That's what we want to put into the calculator, right? So you might want to write that down somewhere because this is going to be kind of tricky. 45w minus 3 over 2w squared. Ready? Here we go. Boom. Okay, so 45w. Well, we don't have w, we have x. Good enough, okay? Minus, now here comes the tricky part. If you have a newer calculator, a lot of people don't realize this. You can actually put a fraction into your calculator. How do you do this? Real simple. You hit the alpha button and you hit F1, okay? So as soon as you do this, watch what happens. A choice comes up right away. Watch this. Alpha, F1. And look at that. You got N over D, which stands for numerator over denominator. And if you hit enter, look what you got. There's your fraction. So you can put 3 over 2 right in there, and it looks exactly like the equation that we've been working with. Now, don't forget the x squared part, right? Okay, so there's your parabolic equation opening down so that we can find the maximum, and it'll be the maximum area. Ho, 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 ho. But I know what you know, and you know what I know. Everything's going to be on Zoom Standard. So look what happens if this is on Zoom Standard on your calculator. That's what the graph's going to look like right now. What a nightmare. That's horrible. Okay, well, so what? Work with it. You realize that this is going to be a parabola opening like this. So right now, this looks like it's curving this way. Okay, the only problem with that is, well, we obviously don't have on Zoom Standard the right dimensions in. So this is where you have to start playing around with the window setting. So basically, if the calculator is showing you this, right? Is showing you this right now on a Zoom Standard, right? And this calculator is way out here. We got to move this window up to be way the heck up here. We got to move this window out to be way out here so we can actually see the entire diagram. So let's start playing around with the window settings. You ready? Okay, here we go. Let's go over the window. Notice the window is at minus 10, 10, minus 10, 10. Okay, so the minimum, x minimum is fine because look, you're way over here. You don't even need this much of an x minimum. You can bring this out to about minus 1 if you want. Well, okay, let's go to the window setting. Let's make this about minus 1 and let's see what happens as soon as we graph this. Ready? Okay. So whoop-de-doo. So we just shorten that up, but we still don't see the other part of the graph. All right, that's fine. Let's go back to the window setting out here now. Let's go to x max. Now, if you think about it, what was the perimeter that we were dealing with? Do you remember? Wasn't it 90? Yeah, I think it was dealing with 90, right? Well, what if you put a x max, which would be the maximum width, at 90? Look what happens. Graph it. Yoink. Oh my goodness, you've overshot this by huge, because you really don't need this, because this is 90 way the heck out here, isn't it? Yeah, looks like you'd only need a half of that. Well, isn't that true? If you got one width, you got another width, you got two widths, you got 90 meters of fencing, the most you need is about 45. So let's go back to this window setting, and let's put this down about 45, and let's see what happens. Graph it. What? Ain't that pretty? Look at that. Okay, so now we've got a width at about 45. But now, obviously, we still don't have the proper height. We can't see the maximum yet. So start playing around with the window settings again. Let's go to the maximum. Y max. Okay, start punching in some numbers. Now, if you're dealing with 90 meters of fencing, do you think you'd probably have an area around 90, 100? Let's try 100. Graph it. Oh, we're getting closer. It's starting to look more like a parabola, but still, it's a lot of guesswork here. So hit the window. Let's go. Let's crank this up. Let's go by 200. Let's see what happens. Okay. Oh, it's getting a lot better. Okay. How about a window setting of, let's say, let's double this. Let's go up to 400 and let's see what happens. Graph it. Hey, ain't that pretty? There you go. There's your nice, beautiful parabola showing that maximum. Let's find that maximum, just like before. Second calc, let's find that maximum. Number 4, left bound, way the heck over here. Perfect. Enter, anchor it. Right bound, anchor it. Punch it. What do you got? I got 14.99999. Yeah. Okay, there's that rounding error that we love so much about this calculator. So our x value, which if you think about it, what was the x value? Wasn't that the width? So our width is going to be 15. And remember, we're dealing with 90 meters of fence. So our width's going to be 15 meters. We don't know what the length is yet. So what is this guy then? Well, of course, that's your maximum. Remember, this was area on this side. Length times width gave us our area. So our area here, okay, the max area, real nice, is going to be 337.5. Oh, 337, forgot the 7. Okay, 337.5 meters squared. There's your maximum area. Ain't that pretty? Wow. Okay, so now that we've got all kinds of information, let's go back into the equation and start solving some things. Okay, here we go. Let's go back to the question. There it is. First thing that it asks us down here in red is, what are the dimensions of the enclosure? Well, the dimensions of the enclosure, we've already got the width. We know that the width is in fact going to be 15 meters. Well, how do you figure out then, how do you figure out the length? Well, you have the formula. It was right here. There's the formula. Okay, you can figure out the length based on the formula. Length worked out to be 45, right, minus 3 over 2, whatever the width was, which was 15. You know what's cool? Why don't you just punch that right into your calculator? Let's bring up the calculator right now. We're going to use that wonderful alpha frac button again. Okay, so here we go. Remember the formula. The formula was back here. It was 45W, 45 minus 3 over 2W. There's our length. Okay, so 45 minus 3 over 2W, our W being, of course, we're going to substitute in the 15. Okay, let's go. Ready? 45 minus. Now, depending on the type of calculator you have, you don't always have to use this alpha and F1. Check your calculator. See if you've got this little symbol right here. Check out what that symbol is. It's going to be really cool, okay? Watch this. I just got to erase it first. Check out this symbol. Real cool. Alpha, boom. Right away puts the fraction in there. And the fraction, you know, is 3 over 2. Bring it out. Substitute in your value which was 15 meters for your width. Punch it. Boom. It does all the bed mass for you. Now, this gives you 45 over 2. Well, sometimes when you're doing measurements, a fraction like that's going to be ugly. So how do you change this? It's actually quite neat. Go back to math, and down here it says take whatever the fraction is and put it into dec. Dec meaning decimal. So take this fraction, put it into decimal. 22.5. Oh, boy, have you learned a lot in this podcast. This is like gold. So 22.5 is, guess what? Your length. So your length is 22.5 meters. And it says the area of the enclosed, total area of each part. Well, area enclosed you found from the original question. The original question, if you remember, when we found the maximum area, it was 337.5 meters squared. You just solved this. Now, what if you want to find the area of the performance area and the eating area separate? Well, since they're exactly the same size, all you got to do is divide this thing by 2, and you got the 2 individual areas. Long question. Sorry it took me 14 minutes to go through the whole thing, but look at all the neat calculator tricks you learned, hey?